Here we have another definite integrals example problem, and this example problem is particularly interesting because we're going to do some u substitution and we want to focus in on our boundary conditions. So here we have the integral from -1 to 5 of 1 plus w multiplied by 2w plus w squared raised to the fifth power. So to evaluate this integral, it's very simple. We'll just use some u substitution like we've done in the past. We'll let this 2w plus w squared term be our u. And after solving for du, we'll go ahead and get 1/2 du is equal to 1 plus w. And so now we have our du and u terms, and we can just go ahead and back substitute those in for our into our original integral. After that, we'll get 1/2 the integral from -1 to 5 of u to the fifth. And so this is very easy to get to this point in the problem, but the one thing we have to remember is that our boundary conditions -1 to 5 are in terms of w. So they're supposed to be evaluated when we have an expression using w. And so now we have an expression of the term u. And so now we'll have to decide whether or not we want to keep our boundary conditions the same or if we want to change our boundary conditions. So before we do that, we'll just go ahead and take the integral and we'll get 1/12 u to the sixth. This is an easy integral to do. And then the next step is we want to decide which method of solving these boundary conditions we want to use. So in the first method, all we'll do is we'll back substitute this u term in terms of w into our original expression, and then we can evaluate it at the original boundary conditions because these boundary conditions were given to us in terms of w. So you can see here, all we've done is plugged in our u in terms of w into our u position. And so now we can just evaluate these boundary conditions like normal, and we'll get a solution. But for the second method, we can go ahead and change our boundary conditions and get boundary conditions in terms of u. And so in order to do that, we'll just go ahead and take our 5 and -1 boundary condition and plug it in for w for our u equation. So our new u will be u of 5 will be equal to 35. And u of -1 will still be equal to -1. And so now you can see we have our integral here, the same integral as before, but we have new boundary conditions. And rather than back substituting, all we have to do is plug in these new boundary conditions in for u, and we'll still get the same solution. So this is just a different method in order to solve by using u substitution.